Hello, and welcome back to our channel. Today, we're journeying back in time, not just by centuries, but by millennia, to a civilization that gazed at the stars with an understanding so profound it continues to astonish us. We're talking about Babylon, the magnificent city of ancient Mesopotamia, a place where science, especially the science of the sky, reached breathtaking new heights. Forget the stereotype of ancient peoples as primitive. The Babylonians were the original masters of data. They were meticulous observers, and for over 1,000 years, they recorded everything they saw in the heavens on small clay tablets. These weren't just casual notes, this was big data, ancient style. They tracked the moon's phases, the sun's path, and the wandering dance of the planets. Why? Well, partly for religious reasons, they believed the gods communicated through celestial signs. But it was also for practical purposes, like creating a reliable calendar for agriculture and festivals. This obsessive record-keeping laid the foundation for true scientific astronomy. Now, let's talk about the engine that powered all this astronomical genius, Babylonian mathematics. If you think math is just a modern obsession, think again. The Babylonians developed a mathematical system that was, in many ways, far superior to what the Romans used thousands of years later. Forget the clumsy Roman numerals like X's and V's. The Babylonians invented something truly revolutionary, a positional number system. This is the same basic principle we use today. The value of a symbol changes depending on its position. In our system, the 1 in 10 means something different from the 1 in 100. The Babylonians did the same, but instead of a base 10 system, they used a base 60 system, or sexagesimal. Remnants of their system are still with us every single day. Why are there 60 seconds in a minute and 60 minutes in an hour? Why does a circle have 360 degrees? You can thank the Babylonians. Their base 60 system was incredibly flexible for calculations, especially with fractions, which made it perfect for the precise measurements needed in astronomy. Using this powerful math, they could predict celestial events with stunning accuracy. They calculated the length of a year to within minutes of our modern value. They developed algorithms to predict lunar and solar eclipses. Imagine, centuries before telescopes, being able to tell your king in 6 months. On the 3rd day of the month of Abu, the moon will be devoured by a shadow. This wasn't magic. It was the result of painstaking observation combined with sophisticated mathematics. They created vast tables of data called ephemerides that listed the future positions of planets. It was the world's first mathematical astronomy. But here's where the story gets truly mind-blowing. For a long time, historians believed that the methods used to calculate the motion of objects with changing speeds, the very essence of calculus, were invented in the 14th century at Oxford and Paris, and then fully developed by Newton and Leibniz in the 17th century. But then, a few years ago, an Assyriologist named Matthew Ossendriger was studying a set of previously untranslated Babylonian tablets. What he found sent shock waves through the history of science. These tablets, dating back to between 350 and 50 BC, contained calculations about the planet Jupiter. But they weren't just tracking its position. The Babylonian astronomers were calculating Jupiter's motion by tracking its speed over time. They figured out that if you plot the planet's speed against time, the distance it travels is represented by the area under the curve. They then devised a brilliant shortcut. They calculated the area of that shape, which was a trapezoid, to find Jupiter's displacement across the sky over a certain period. This is an incredibly abstract concept. It's the idea of representing time as a dimension in a geometrical space, and then using the area of that abstract shape to find a physical result. This is a foundational concept of integral calculus. The Babylonians were using geometric techniques to do what we now do with calculus a full 1,500 years before it was supposedly invented in Europe. This discovery completely rewrote the timeline of mathematics. It showed a level of abstract theoretical thinking that no one thought was possible for that era. They weren't just plotting points in the sky. They were plotting points in a mathematical space. They were calculating the area of a velocity time graph. Let that sink in. These ancient scribes, working with styluses on wet clay, were performing a type of proto-calculus to understand the cosmos. This is not to say they developed the full system of calculus like Newton did, but they grasped one of its most fundamental principles independently. So what does this all mean? It means the history of science is not a simple, linear march from ancient ignorance to modern enlightenment. It's a complex, fascinating story with brilliant peaks in unexpected places. The civilization of Babylon, which rose from the dust of Mesopotamia, was one of those brilliant peaks. Their legacy isn't just in crumbling ruins, but in the way we measure time, the way we divide a circle, and in the very foundations of astronomy and mathematics. They were the first to show that the universe wasn't just a realm of unpredictable gods, but a system that could be understood, measured, and even predicted through the elegant language of numbers. The story of the Babylonians is a powerful reminder that genius can be found in any age. It encourages us to look at the past not with arrogance, but with a sense of wonder and respect for the incredible minds that came before us. Thank you so much for joining me on this journey back to ancient Babylon. If you enjoyed this deep dive into the history of science, please give this video a thumbs up and consider subscribing to the channel for more stories that challenge what you think you know about the past. We'll see you in the next one.